Hello students, welcome for today's session. In today's session, we will understand how we are going to create a well-formed XML document and what do we mean by when we say an well-formed XML document. So we'll watch a video to understand about the topic.
We've given a little bit of an introduction to XML. We've talked about how at the lowest levels XML is based on text characters, and those text characters have to be represented in a particular encoding of bits. Let's take it up one level and assume that we've got characters available to us in a file. How do we take those characters and make sure that we have well-formed XML with a proper syntax that can be parsed and understood by computer programs? To do that, at a high level, what I want to communicate is that XML has a simple syntax for representing tree-like data. And although the rules for making XML are very simple, they can actually create very sophisticated and complicated data sets. The whole idea of a properly formatted XML document is based on the idea of tags, or elements, and the fact that they're properly nested within your document. So properly nested elements or tags. We've already looked at characters, and so what this lecture is going to look at is the tag levels of XML. XML has flexible tags. We've already seen this particular example of a piece of XML that we made up as an example. This one's taken from w3schools.com. And in it, what you can see is that the tags have some metadata associated with them. You know that this is a note of some kind. There's a to, a from, a heading, and a body. So those tags were defined by me. No one else made them up. And when you write an XML document, you're free to invent your own tags. Now, the tags that you use might be constrained by the kind of software that you intend to have reading your tags. From and to, in that example that we have right there, they're not defined anywhere official. They were invented by me as the author. And in general, XML doesn't have any predefined tags. That said, particular software, particular purposes, expects to find some kinds of tags there eventually. Contrast this, for example, with HTML. In HTML, there's this idea of tags where you have things like the p tag for a paragraph or an href tag for a hyperlink. Those are tags that have roughly the same structure as XML, but they are predefined. They're a certain kind of tag that's part of the HTML structure that's defined, and what it means to put a p tag or an href tag in an HTML document is well known. In XML, the author defines the tags and the structure within the bounds of valid XML syntax or valid XML structure. So it's important to point out that XML is not a replacement for HTML. XML is a more general version of HTML. And in that way, XML complements HTML. XML clarifies a more formal standard for HTML. If you have an HTML document and all of the tags are properly nested and opened and closed, meaning that the HTML tags are XML syntax compliant, then that document is probably also XHTML, or one of those rare documents that's both valid HTML and valid HTML. That means that the document only has tags that are defined by the HTML standards body, or W3C. XML was designed in order to separate data from a presentation. The data can be transported as the XML file, and some other program, possibly like a browser or anything actually, has the opportunity to render that data in any way you would like. XML simplifies data sharing because it enables structured data to be shared in a way that's system and platform independent. It simplifies data transport, moving across the network. It simplifies platform changes. If you want to use data on one platform, OS X, or on another one, Windows, the XML standard becomes the interface through which those systems can communicate. And as a result, XML also makes your data more available because more platforms can use it. XML is also used for new languages. So, for example, XHTML is a new language. It's a version of HTML that's based on XML. But there are other ones like, they're always alphabet soup, right? They're always acronyms. But WSDL is a language for describing web services. And in the same way that HTML is an XML document with predefined tags, WSDL is also an XML document with predefined tags. If you've ever used a newsfeed reader, newsfeed readers rely on getting an RSS file, a file whose extension is RSS, and RSS itself is a particular set of tags that are expressed using the XML syntax. RDF and OWL are used for describing the semantic web or resources and ontologies, and XAML or XAML is used for describing user interfaces on the Microsoft platform. Again, it is an XML document that has a certain set of tags that are expected by Microsoft software. XML, because of the way it uses tags, produces something that can be interpreted as a tree structure. Every XML document has one root and can have multiple child elements and multiple subchild elements. Tags always form the beginning and the end of an element. So an opening tag, for example, looks like this. I guess it's over on my right. The word tag embedded within angle brackets, a less than symbol and a greater than symbol, is an opening tag whose name happens to be tag as well. The closing tag also has a slash in front of the name of the tag to which it is closing. So that's an opening and a closing tag. So every XML document, every valid XML document, has exactly one closing tag for every opening tag. A valid XML document always has opening and closing tags in pairs. Here's an example of how we might envision a XML document being interpreted as a tree. So on the left side, we see a representation of a bookstore database. And this bookstore database has a handful of tags that you can probably interpret here. The root tag in this example is the bookstore tag. It occurs at the top and the bottom. You can see the opening bookstore tag has no slash, and the closing one at the bottom does have a slash. And if you look over at the diagram, I guess the diagram behind me, there is a bookstore tag up there. And that node in that diagram represents the outer enclosure of the bookstore tag in the XML document. As you look at the first child of the bookstore tag, that is a book tag. The first book tag has an attribute called category, which we haven't talked about yet, and that category is cooking. And that book tag has an opening and closing book tag. Now you may notice there are actually 3 pairs of book tags that are children of the bookstore tag. They are siblings of one another in the tree structure. The first book tag has 4 tags that are children of it or embedded within it. A title tag, an author tag, a year tag, and a price tag. And then ultimately those tags each have data that's associated with them. And so that's text that comes in between the opening tag and the closing tag. So for example, the year of publication of that first book is 2005. And as you look at the tree representation of it, you can see how a tag that has an opening and closing element is the parent of all of the tags that exist within it. So the diagram on the right shows the interpretation of the bookstore and the first book on the left. Now the second book has the same children, a title, author, year, and price, and they create a tree structure as shown in the middle. And then finally the last book has a tree structure with also a title, an author, a year, and a price. Different data, similar tags, all children of the book tag, and the book tag is children of the bookstore tag. There's some details that are required to make sure that this is a valid XML tag structure. So as I said, each XML tag must have a closing tag. So compare this to HTML. In HTML, it would be valid in order to have a p tag that starts a paragraph and is never closed. So you might have one paragraph listed there as this is a paragraph, followed by second paragraph, this is another paragraph. In XML, that wouldn't fly because every opening tag has to be paired with a closing tag. So properly transforming that HTML into XML syntax would require you to put a closing paragraph tag at the end of the paragraph, starting with the P, ending with the /P. The next paragraph would start with its own opening tag and end with another /P. So in XML, every opening tag has a paired closing tag. In XML, there is a shortcut that can be used to open and close a tag in one element. And that is, for example, if you have the tag like we have here with nothing and then slash nothing, so a nothing tag. And if there's nothing that's in between the opening and closing tag, so just the presence of the tag itself is all the data that you need in the document, you can create a shortcut which reduces the number of characters that are needed to represent the opening and closing tag by changing that first set of 2 tags into a tag that is nothing and then slash immediately. The second case of the nothing example represents both an opening and closing tag. So in HTML, we might have something like image source equals picture.jpg and not have any closing tag. That's not valid XML. Valid XML requires us to either have a close image tag or to embed the slash into the opening tag so that it is opened and closed within the same tag structure. So the first 2 nothing examples are valid XML, and the last 2 examples are valid XML, but the one without a closing is not valid XML. XML tags are case sensitive, and so if you have a tag that starts with a capital M message, it is not correct to close it with a lowercase m message. The tag either has to have lowercase at the beginning and the end, or capital at the beginning and the end in order for it to be proper XML. In XML, all tags have to be correctly nested, meaning any tag that was opened has to be closed before another tag that had been opened before it is closed. This isn't really true in HTML. So for example, in HTML, if you wanted to make text that was to be presented as both bold and italic, you might have a B tag and then an I tag, the text then that you wanted to be bold and italic, and then have it closed by a close B and a close I tag. Now the reason why that's not valid XML is because the I tag has to be closed before the B tag is closed. So the second example shows how it's valid, how that example can be transformed into valid XML. The italic tag has to be closed first because it's nested within the B tag. And that nesting property is what gives the overall XML document its tree-like representation. Finally, all XML documents must have a single root element. And so this is whatever the topmost tag is that is enclosing all of the children tag. So in the bookstore example, bookstore is the root. In this example here, next to the bullets, the word root forms a root tag, which is the top level tag of the tree. Now, as I demonstrated before in the bookstore example, tags can also have attributes. And attributes are just kind of sub-tags, descriptors, which provide a little bit more information about a tag. It consists of a word that's also in the opening tag, followed by an equal sign, and then some text which must be within quotes. It must be a string that is within quotes. That is the value of that attribute. So an invalid example of putting in a date attribute into the note tag is this first example. It's invalid because although the date string is fine, it's not enclosed within quotes. The second example demonstrates properly generated XML syntax for an attribute, in which the value of the date attribute of the note tag is enclosed in double quotes. Now this attribute structure is a little bit funny because it turns out that attributes can be interchanged, and I'll demonstrate that in a second. There are some special characters in XML that you have to be careful of. For example, if you actually want to have a less than symbol as part of the data associated within a tag, for example, you wanted a paragraph in HTML and you wanted a less than in it, you have to do something special because if that less than symbol is read by the XML parser, it's going to be interpreted as the beginning of a new tag. And so, for example, if you want to have a message where the message opens with a message tag and closes with a message tag, and you want the message itself to be something like, if salary is less than 1,000, then, maybe it's a little bit of a snippet of code that you're writing, that less than symbol is going to screw up the parser because the parser is going to think that you're starting a tag whose name is 1,000. And there are 5 characters that are like that: the ampersand, the less than symbol, the greater than symbol, the double quote, and the single quotes. So if at any time you want to include those within the text portion of your XML, then you need to use not the symbol itself, but a special symbol, which is an ampersand, the letters, and a semicolon, which then gets translated into the literal character. So this is called escaping certain characters. So if we wanted to represent that if salary is less than 1,000 then message within the message tag, we'd have to do what we did at the bottom, where we say if salary ampersand LT semicolon, which gets converted into a less than symbol by the parser, 1,000 then message. That ampersand syntax doesn't confuse the parser into thinking that a tag has been begun. In XML, you can have comments, and comments have a slightly different form. They start with an angle bracket, an exclamation mark, and 2 dashes, whatever comment you want to have, and then the comment is closed by 2 dashes and an angle bracket as well. It's kind of unfortunate that it doesn't follow the strict XML syntax. It would be nice, for example, if it ended with a / exclamation mark dash dash, but it doesn't. In XML, white space between tags is preserved. So for example, in this message example, there is a lot of spaces between the is and the and several spaces between the a and the lot. Those spaces are part of the data and they're retained when the XML document is transferred. Any spaces that are outside of the message tag is not part of the data itself. Finally, as I mentioned previously, attributes and elements are pretty interchangeable in terms of their representational power. So take this example of trying to represent a person whose first name is Anna and last name is Smith. If you would also like to capture her gender within the data of this XML document, you could either do it by assigning an attribute called gender to the person tag and setting that equal to the string female, or you could do it by eliminating the attribute tag and adding a new child tag to the person tag. That new child would have that tag value gender, and you would include the data of the character's female in between that tag. So the first example and the second example, very nearly interchangeable in terms of their representational power, but just different ways of structuring your data. Here's another example of attributes and elements being pretty interchangeable. This is that same note example we started with. And in this case, we want to apply a date. Maybe it's the date at which the note was created. Well, we could either do that by adding an attribute to the note tag, which is called date, and which as a string has the date when it was created. Or we could maybe push that down and make the date attribute become a date tag, whose text value is 10/1/2008. Or maybe we could push it down even further and split up that date data into children tags of the date tag, the children tags whose names are day, month, and year, and then put the data itself within each one of those sub-children. So a lot of different ways of representing the data. How you choose to do it is kind of up to the author's choice and the person and the programmer or the code that's being used to interpret and understand that. So, in summary, XML uses flexible tags to create structured data. Tags must be nested, and tags must have an opening and a closing, and they must come in pairs. There are several other details that are required for having valid XML, like matching capital letters and using escaped characters. But at the end of the day, if you meet all those requirements, you have a valid XML document. And the result will be a data structure that can be represented visually as a tree. Thank you for your attention.
Students, we have tried to understand how we can create a well-formed XML document. So there are certain rules that we need to follow. The first one is that it should have a corresponding end tag for all the starting tags. Nesting of the elements within each other must appear properly. In each element, two attributes must not have the same value. Markup characters must be properly specified. And an XML document can contain only one root element. So, the root element of an XML document is an element which is present only once in an XML document, and it does not appear as a child element within any other element. So in the next session, we will try to understand what do we mean by a valid XML document. See you in the next session. Thank you.